We're continuing on our theme here of combining things that have exponents. And today what we're looking at is actually specifically adding and subtracting things called polynomials. The first thing we need to do is look at what is a polynomial, and then we'll look at how to add and subtract them. And for the rest of this little unit, we're going to talk about different ways to combine polynomials, like multiplying them and dividing them. Today specifically, we're just talking about adding and subtracting polynomials. But first off, what is a polynomial? A polynomial is just a combination of numbers and letters, numbers and variables, that are added and subtracted together, okay? It's just numbers, variables, and exponents. There's nothing special like trig functions like sine and cosine or exponentials. Here, these are examples of polynomials down here. This is actually a polynomial in and of itself, but each term of a polynomial is separated by a plus or a minus. So I could give you an example. If I had negative 12 z to the 7th plus x to the 3rd plus 10w plus 7. This is a polynomial. It's not in one variable, but it is a polynomial because it has only numbers, variables, and exponents that are combined with addition and subtraction. Each of the things that is separated by addition and subtraction is called a term. So this is a term. This is a term. This is a term, and that is a term. All four of those are terms because they're separated by addition and subtraction. Each of these terms has a coefficient and an exponent. So the coefficient is the number out front, to the left side, I should say. That's the coefficient. That's the number that's multiplied by the term. So negative 12 is the coefficient there. The sign goes with it. The coefficient here is negative 12. The coefficient here is 1. The coefficient here is 10. The coefficient here is 7. They also each have an exponent, which is called the degree, and I'll just label that in purple here. The degree is 7, 3, 1, and 7 for each of those terms. I'm sorry, and 0 for each of those terms. 1 and 0. The degree of the entire polynomial itself is just the highest degree of any single term. So the highest degree we have is 7. That's because of this exponent here, not because of the number out to the right. It's because of the highest exponent is 7. Here are some examples of that. There are some ways to categorize these. A polynomial with one term is called a monomial. A polynomial with two terms, notice that has two terms, 1, 2, is called a binomial. A polynomial with three terms, 1, 2, 3, is called a trinomial. We almost always want to write our polynomials in descending order. So back here, notice that it went from the highest exponent to the next highest, to the next highest, to the lowest. We go from the highest exponent down. That is descending order. So in descending order, this here, notice it has a y to the 3rd and a y to the 5th. We want the y to the 5th to come first for it to be in descending order. So in descending order, we're just going to change the order of it. Negative 6y to the 5th plus 4y to the 3rd. Here in descending order, this item has a variable and the other does not. So the degree of this is 1 and the degree of this is 0. So we want the first degree piece first. The leading coefficient is the first item that comes when you write it in descending order. So that's the leading coefficient. And the degree, like I said on the last slide, is the highest exponent. So the degree here is 4. The degree here is 0 because there's no variables. The degree here is 5. The degree here is 6. The degree here is 1. It's an understood 1. And the degree here is 8. So given this polynomial, let's first list the terms. This is part A. List the terms. The terms are 3a, negative 2a to the 4th, 6, and negative a to the 3rd. Those are all of our terms. If we want to write that in descending order, that means we want to write it with the highest exponent first. So that would be negative 2a to the 4th minus a to the 3rd plus 3a plus 6. We want our highest exponent all the way down to the lowest exponent. State the degree of the polynomial. The degree of the polynomial is the highest exponent. So here the degree is 4. That's the highest exponent. And we have seen polynomials where we want to evaluate. If we want to evaluate for a equals -2, that means we want to substitute in a -2. And I'm actually going to use this part here. So -2 times -2 to the 4th. Remember, we're evaluating for a equals -2 minus -2 to the 3rd. And every time we evaluate, we're going to put that variable in parentheses every time. And so I'm just putting a -2 in to the blank there. And I'm going to do each piece separately. And then if I combine all of those together, I'll get -24. So when we evaluate, we're trying to get a numerical value. And we're subbing in our value for our variable. And we're always going to sub it in parentheses. All right, when we want to add polynomials together, so let's say we had 2 of those things on the last slide. If we want to add them together, they have to have like terms to be able to combine. We can only combine like terms. Now, like terms have the same exact variables to the same power as well. They have to have the same variable to the same power. So, for example, these two here, 3x squared and -7x squared, they have the same variable x to the same power 2. That means we could combine those, and that would make -4x squared. The way that you combine them is by adding the coefficients. Here, these have the same variables y and z to the same power. Z is to the 3rd power. So -5 plus 1 equals -4, my y, z to the 3rd. Notice I did not change the variables. I didn't make that x to the 4th. On this example, I didn't make it x to the 4th. I left it as x squared. I'm just changing the amount of it I have. I have 3 of those things, minus 7 of those things makes -4 of those things total. How about these? These are not like terms because they both have z's, but the z's are not to the same power. So these are not like terms. I cannot combine them. These are not like terms because I have a w in one and a p in the second one. And these are not like terms because one of them has a y and the other doesn't. When we're adding like terms, I mentioned this on the last slide, we're not going to combine the exponents. 2x to the 3rd plus 3x to the 3rd is not equal to 5x to the 6th. It's equal to 5x to the 3rd. We're just changing the amount of x to the 3rds that we have. We have 2 of them plus 3 of them gives us 5 total of the same thing. Same thing here, 3 plus 9 minus 2. They all have an x squared. 3 plus 9 minus 2 is equal to 10. And so that gives me a total of 10x squared. The same type of thing, just more or less of them. Let's try these. Add these polynomials. Notice they both have an x squared and a y, so I know my answer is going to have an x squared and a y. How many of them? 3 plus 5 is 8. Try the second one. Notice they both have an a squared and a b to the 3rd, so I know my answer is going to have an a squared and a b to the 3rd. 13 plus 2 makes 15 of those. When we're adding polynomials with multiple things, we're again just looking for like terms. So here, this is addition, right? This is addition. So -3 plus 11, those are like terms because they both have c to the 3rd, makes 8 of those items. 5c squared and 6c squared, they both have c squareds, makes 11c squared. And -7c, there's no other c item out here, so that's just going to be -7c. Plus 3, again, there's no item with just a number, so that's just going to be plus 3. And that is my answer. Try it on that second one down there. You've got q squareds that can combine. You've got q items that can combine. And you've got numerical items that can combine. And here's what happens when you combine them. Here's a couple more problems. -4w squared plus 3w squared makes 7w squared. I have an item with an x, an item with an x. That makes 4 of those x's. -2 plus 6 makes 4. And that has nothing to combine with. And so that is going to be my answer. Same thing on the next one. Pause it, Try it, and here's what your answer should look like. Subtracting polynomials is a little bit different. Notice in all those problems that I just did, there was a plus sign in between, right? Plus sign in between the parentheses. Plus sign means I'm just combining like terms. When you have a minus sign between them, you have to distribute that negative to everything in the second parentheses. So I'm just going to rewrite my problem now. Negative 4p to the fourth plus 5p squared minus 3. And now if I distribute that negative, negative 11p squared, negative 4p, negative times negative 6 makes positive 6. It's almost like I'm multiplying everything by negative 1. That's the same thing as a negative 1 there. And you have to multiply that negative 1 to every item in that parentheses. Now can we combine like terms? Is there any other item with a p to the fourth? I don't see one. How about items with a p squared? Positive 5 and negative 11 makes negative 6p squared. Items with just p's, there's only one of them. And items with that are just numerical. Negative 3 plus 6 makes positive 3. That is going to be my final answer. The only difference between this and the last problems was there was a negative in between, and so I distributed a negative 1 to everything in that second parentheses. Here are some more examples of that. Subtract this polynomial. The first thing we need to do is distribute the negative through. So x squared plus 3x minus 2 minus 4x squared minus 6x minus 1. And now combine like terms. Combine your like terms with just x's. And combine your numerical terms. And that's going to be our final answer there. Oh, I'm sorry, this is x squared. Those first items there made an x squared item. All right, I've got two more for you to try. Again, I would pause the video, try and attempt it on your own, and now I'm going to show you how I work these problems. First, distributed the negative, and then combine like terms. Same on the second problem. First, distributed the negative, and then combine like terms. All right, last slide here. The wording of this matters. Remember that subtraction is not commutative, so it matters the order that you do subtraction. If I said, for example, subtract 5 from 10, the way that you would write that is 10 minus 5. The order there flips. When you say subtract so-and-so from so-and-so, subtract x from y, then we're going to do y minus x. We always change the order. So if I say subtract 1/3 t to the fourth plus t squared from t squared minus 4, what I'm really thinking about is t squared minus 4 minus 1/3 t to the fourth plus 1/2 t squared. This looks similar to those last problems. I need to distribute the negative. So that's t squared minus 4 minus 1/3 t to the fourth minus 1/2 t squared. And since I'm trying to get descending order, I'm going to start with my highest variable first. Then my next highest variable is t squared. And then the only thing left is numerical values. Try that on the second example. I'm going to reveal my answers here. Subtract the first one from the second one. Distribute the negative, and combine like terms. All right, in the next video, we're going to talk about multiplying these polynomials. And then after that, we're going to talk about dividing the polynomials as well. Make sure that this is solid, okay? Make sure that you go back and practice this as much as needed and that you have this solid before you move on to the next video. Because when we multiply polynomials, we are still going to have to know how to combine like terms. All this information sort of snowballs, so make sure you're good with your exponents. Being good with your exponents means then you can move on to adding and subtracting like terms. And then once you're good at adding and subtracting like terms, then we can move on to multiplying polynomials.